Hello folks, this is an AM radio on a single chip. Where you think, well, what's so special about that? What's special is that this is on a microcontroller. So it's using all the peripherals on the microcontroller in order to be able to do an AM radio. And we show this by, we've got the antenna input here, and then we've got the audio output, which plops around here somewhere. I'm sure I can find it. There we go. And then goes into our amplifier, which is a spinal tap amp, of course, and of course it does go up to 11, because 11 is better than 10, isn't it? And in case you didn't know, Spinal Tap have got a new movie out in the next couple of months, so there you go. I thought it'd be a good time to get the Spinal Tap amp out. So let's have a look. So the input here is an SMA, which just comes from a mini whip antenna, terminated with 47 ohms, and then it's AC coupled, and then we've got a resistor into the negative input of an op amp on the chip itself. And this op amp is configured with these two resistors to have a gain of 17 dB, and it's a 2K and a 15K, and then that just goes straight into an ADC input. And then the ADC input does a whole bunch of processing. The ADC itself samples at about 16 megasamples a second, and in hardware it over samples, gives us 4 megasamples a second with 13 bits, which is then processed entirely in software, immediately converted to float. We do a quadrature mix with sine and cos in floating point, and everything, all of the DSP processing is done in floating point. It goes into a low-pass filter, uses a polyphase deconstructed CIC filter and decimation of 128, so you've got a low-pass filter. Then it goes into an FIR compensation filter to give us a 6 kilohertz bandpass filter with a sample rate of 31.25 kilohertz. And then that goes into a demodulator, very simple demodulator. It just takes the I sample and the Q sample, squares each of them, adds them together and square roots them. And this is all done in floating point. Then applies an AGC to it, and then provides the output to the DAC, which is what we can hear here. If I
suffered.
Everything has been.
This is Radio 4.
Belongings are gone. Even our clothes.
I don't know how long Radio 4 is going to last. There's some talk of it disappearing off in the next few months. So we may have no long wave anymore in the UK. So in case people didn't know, long wave is also used to control the metering for electricity. So that if you do your things like your washing and whatnot in the middle of the night when electricity is cheap, that uses the 198 kilohertz Radio 4 signal to do that. So it's not clear what's going to happen to that when Radio 4 goes off the air in a few months' time, whether or not that's still going to be there. Anyway,
the strike next month to protest against the government.
I should have added that as well as this little I2C LCD display, there's a rotary encoder, so we can do some tuning. So
the British Horse Racing Authority says the sport is worth £4.1 billion to the UK
we can
economy.
receive. There's nothing else on long wave that I can get here. So see, it goes into up to medium wave. There's something there, 558 kilohertz. So I think it's Punjab radio or something. Something around here. There we go. 648 kilohertz. Now I'll essentially have a look at my notes and I'll tell you what these are. This is 648 kilohertz, this is Radio Caroline apparently.
United 0.
693 kilohertz.
Arsenal with the corner. Saka with the in-swinger.
BBC Radio 5 Live.
We've got
837 kilohertz, that's BBC Asian. 873, BBC Norfolk.
He's not one who gets involved
909,
in link-up lane, build-up
BBC
lane.
Radio
He
5.
deserves
Actually, I missed one. 693, there should be a Radio 5 line as well.
Oscilloscope.
Yeah, did we get that? Okay, 873. What's the next one? BBC Norfolk.
Harriet start.
909.
Amagiello.
It's BBC Radio 5 again on a different frequency. The next one I think is 1053. A little bit faint. This is Talk Sport. Now, Talk Sport is actually on 3 frequencies, very close to each other. There we go, Talk Sport again. And this is Talk Sport as well at 1107. And then there's virtually nothing that I can pick up. I've got a load of noise on medium wave. There we go, 1449. This is BBC Asian. So if you go there, there's nothing else. There's something that goes down to the long wave again. I don't know what this is. Sounds a bit like RTTY, but I'm sure somebody will be able to tell us what it is at 144 kilohertz.
Warriors
And
Consortium.
here we go.
The
We're back to Radio 4. And yeah, let's just show you what's going on here on the scope. So we can see here on the FFT here, the marker, that's on 198. So there's a peak there, which is our Radio 4 that we're listening to right now. That's the output of that 17 dB op amp. See here on the D3 trace, this is the how when it's actually spending time processing. So when it's high, that's actually doing processing. So we can see here on the duty cycle here that it's about 73.6 or something. So 73.6% of the time it's actually spending time doing all of that DSP goodness. So that gives you an idea of how busy it is with 4 megasamples per second. Now you remember I mentioned it decimates it by 128. Well, 4 megasamples per second decimated by 128 gives us this 31.25 kilohertz, which is the frequency of. So you see it as a batch processing of 128 samples at a time. The green trace, that's the output of the op amp, and I've got that on here. You'll notice that I'm looking at the peak to peak here, so I'm trying to make sure that the peak to peak doesn't overdrive the op amp, sorry, the ADC input. So it's pretty reasonable here at the moment with these values. And that's the reason why it's a bit of a weird value at 17 dB is because on the op amp gain, that's because it was 20 dB was a little bit too much. So I was on occasion I'd see it clipping. So that's not very nice to your signal, to your demodulation or anything else. And this is the DAC output, the demodulated DAC output, and you'll see that also it ties in with these the 31.25 kilohertz, where you see the steps in the signal here when a new decimated and demodulated signal is applied. So if I stop it during some actual chit chat, there you go, you'll be able to see. You'll see that this is a demodulated output here, and the steps which tie in exactly with the 128 decimated. So it's 31.25 kilohertz sampling rate on the DAC output. So I think that probably pretty much covers it. And so it running again. And we'll listen to
Sport Productions will
Radio
explore
4.
such themes as abuse, pressures on the education system, aging and money, with stars such as
Thank you for watching.